All right, so what we're looking at now is the Zener diode in a DC application. All right, so in this circuit, I have R1, R2, and I have the Zener diode. So notice a couple of things. This is a variable DC power supply, so we are back in DC. A resistor that is 1K, another resistor that is 1K, and then a Zener diode with a Zener voltage of 3 volts. So, I want to ask you a question. Is this Zener set up for forward bias or reverse bias? So remember, that's my anode and that's my cathode. So take a second, pause, and decide whether it's forward bias or reverse bias. Okay, so the positive is tied to the anode. So that means that the anode is going to be more positive than the cathode. So that means that this is forward bias. So this chart is super easy. So remember what we said in the previous video that gave the Zener characteristics. When the Zener diode is forward biased, what does it act like? A general purpose diode. So that means that once we reach 0.7 volts here, this locks and they stay at 0.7 volts. And until we lock, it's an open, so this is just a series circuit. Okay? So, let's go back through this. And like I said, this will be a little bit of a review from some of the previous circuits. So at 0.2 volts, is that enough to lock this diode? It's not. So if I have two equal value resistors, so this is open, so it's just a series circuit. So the 0.2 volts is going to split with R1 and R2. Because 0.1 plus 0.1 equals 0.2. So since the diode is open, remember R2 and the diode are going to read the same. So VD is 0.1 volts. 0.4 volts, still not enough to lock it. So 0.2 and 0.2. And since R2 is 0.2, the diode is also 0.2. Is 1 volt enough to lock the diode? Not yet. Even though we are above the 0.7, remember, this has to reach 0.7 volts before this will lock. And since I have two resistors in here, I'm going to have 0.5 and 0.5. And then the diode will be the same. Now, at 2 volts, now I have enough to lock the diode. Because if the diode wasn't here, this would be 1 volt, and this would be 1 volt, which is more than 0.7 volts, so the diode is locked. So that means that the diode will be 0.7, and that means R2 will be 0.7, and then VR1 is what's left. So 2 minus 0.7 is 1.3. So remember, this is going to look just like the charts we've already done because the Zener is forward biased. So it acts like a general purpose. So that means from here down, these are going to stay locked at 0.7. And then what is left will be here. So 4 minus 0.7 is going to be 3.3. 6 minus 0.7 is going to be 5.3. And 10 minus 0.7 is going to be 9.3. So that's what my voltage chart would look like with a Zener diode in forward bias. Okay? So again, just like what we've already done, because a Zener in forward bias is going to act just like a general purpose diode. And that goes for every Zener diode. Doesn't matter if VZ is 200 volts. In forward bias, it's going to act like a general purpose, 0.7 volts. So now, let's redo this chart with the Zener facing the other way. So, I'm going to take, and I'm going to flip the Zener around. I'm going to relabel my anode and cathode. So this is cathode and this is anode. So now, my cathode is more positive than my anode. So that means that this is going to be reverse bias. So think back to the previous video about my Zener diode characteristics. In reverse bias, the diode will remain open until we reach the VZ. And once we reach the 3 volts across this diode, we lock at VZ. Okay? So that means that this is going to be used to lock my output voltage at 3 volts once we reach that certain amount. You're going to see this used extensively in rectifier circuits. You take AC, convert it to DC, slap a Zener on the output, and you can regulate whatever you have. Because your transformer is going to be a pretty high voltage. 24 volts AC, 120 volts AC. So your job is to rectify that to a usable DC signal and then use the Zener to regulate that output. Kind of like your automobile, okay? Your automobile has a voltage regulator in it to keep your voltage at a certain level. That's what the Zener's job is, okay? So, we have to reach at least 3 volts here before we lock. So remember, until we reach that 3 volts across here, this remains open. So the voltage is still going to divide between R1 and R2. So 0.1 volt or 0.2 volts, definitely nowhere near 3 volts. So I'm going to split the voltage, and then VD and VR2 read the same. 0.4, definitely not enough. So 0.2, 0.2, and 0.2. I think y'all get the point there. 1 volt, still not enough. So 0.5, 0.5, and 0.5. 2 volts, still not enough. So 1 volt, 1 volt. R2 and diode reads the same. 4 volts. Is it enough? Nope. Remember, this has to be at least 3 volts to lock it. Okay? Because remember, until we see 3 volts here, this remains open. So this 4 volts is going to split 2 volts and 2 volts with the 2 1Ks, and this will be 2 volts. What about 6 volts? 6 volts is just enough to lock it. So I'm going to have 3 volts, 3 volts, and 3 volts. So at this point, that diode is going to start conducting in reverse bias. Okay? So if this was a general purpose diode, we'd say that this is 5, 5, and 5 because it never actually closes. However, since this is a Zener, now that we've reached the 3 volts of Zener voltage, these stay locked at 3, and what's left is at R1. So 10 minus 3 is 7. And we can keep going. If this were 20 volts, these stay locked at 3, and what's left is 20 minus 3, which is 17. If this was 50 volts, guess what? These stay locked at 3, and what's left is VR1, which would be 47. So the point is, once you reach VZ at R2, these two will lock at whatever VZ is, and the rest is left at R1. Okay? So, hope that makes sense. So again, forward bias, this acts like a general purpose diode. Reverse bias, once you reach VZ across these 2 branches, it locks and the rest is at R1. Okay? So, from a DC standpoint, that is all there is to a Zener diode. Okay? So, we're going to take a pause there. We're going to work through the DC aspects of things. And then once we nail that down, we're going to move into the AC side of things. And we have one more small circuit type to go over, and then the next test will be once you guys come back. Okay? So I hope this makes sense. Again, like I say in every video, if you have any questions, please reach out and let me know. Okay? So you guys have a good rest of your day.